Hello Stormwater designers, welcome back to Clear Creek Solutions instructional videos, and today we're going to be going over the minimum requirements again. We're on a minimum requirement number 7, and this is flow control, so we're just going to dive in. We're going to look at a small modeling scenario in wwhm 2012. So with minimum requirement number 7, flow control, projects shall employ flow control BMPs in accordance with the following thresholds, standards, and requirements to reduce the impacts of stormwater runoff from hard surfaces and land cover conversions. So minimum requirement TDA exemption, flow control is not required for TDAs that discharge directly to or indirectly through an MS4 to a water listed in Appendix 1A, flow control exempt receiving water subject to all the following restrictions. Direct discharge to the exempt receiving water does not result in the diversion of drainage from any perennial stream classified in types 1, 2, 3, or 4 in the state of Washington interim water typing system, or types S, F, or NP in the permanent water typing system, or from any category 1, 2, or 3 wetland. If flow splitters or conveyance elements are applied to route natural runoff volumes from the TDA to any downstream type 5 stream or category 4 wetland, then design of the flow splitters or conveyance elements must be based on approved continuous simulation modeling analysis. The design must assure that flows delivered to type 5 stream reaches will approximate but in no case exceed durations ranging from 50% of the 2-year to the 50-year peak flow. Flow splitters or conveyance elements that deliver flow to Category 4 wetlands must also be designed using approved continuous simulation modeling to preserve pre-project wetland hydrologic conditions unless specifically waived or exempted by regulatory agencies with permitting jurisdiction. The TDA must be drained by a conveyance system that is comprised entirely of man-made conveyance elements, e.g. pipes, ditches, outfalls, and extends the ordinary high water line of the exempt receiving water. The conveyance system between the TDA and the exempt receiving water shall have a sufficient hydraulic capacity to convey discharges from future build-out conditions under current zoning from contributing areas of the site and the existing condition from contributing off-site areas. Any erodible elements of the man-made conveyance system must be adequately stabilized to prevent erosion under the conditions noted above. Local governments may petition Ecology to exempt projects in additional areas. A petition must justify the proposed exemptions based upon a hydrologic analysis that demonstrates that the potential stormwater runoff from the exempted area will not significantly increase the erosion forces on the stream channel nor have near-field impacts. See Appendix 1A, Flow Control Exempt Receiving Water, for details. Each TDA within a project that requires minimum requirement number 7 must be reviewed to determine if flow control BMPs are required for the TDA to be in compliance with minimum requirement 7. Note that it is possible for a project that requires minimum requirement number 7 with multiple TDAs to not need flow control BMPs in one or more individual TDAs. If a TDA does not trigger the TDA thresholds for flow control BMPs, then the designer must document the areas within the TDA used to determine that the TDA thresholds were not met. This documentation will demonstrate compliance with minimum requirement number 7 for the TDA. When assessing a TDA against the following thresholds, only consider the types of surfaces, e.g. new hard surfaces, replaced hard surfaces, converted vegetation areas that are subject to minimum requirement number 7 per the project thresholds in 133 applicability of the minimum requirements. The following TDAs require construction of flow control BMPs to achieve the flow control performance standard. If a TDA meets any of the following thresholds, flow control BMPs are required. The project proponent must demonstrate that the TDA does not meet any of the following thresholds for flow control BMPs do not be required for the TDA. TDAs that have a total of 10,000 square feet or more of effective impervious surfaces, or TDAs that convert 3/4 of an acre or more of native vegetation, pasture, scrub, shrub, or unmaintained non-native vegetation to lawn or landscape, or convert 2.5 acres or more of native vegetation to pasture, and from which there is a surface discharge in a natural or man-made conveyance system from the TDA. Or TDAs that through a combination of effective hard surfaces and converted vegetation areas cause a 0.15 cubic foot per second or greater increase in the 100-year flow frequency as estimated using continuous simulation. The 0.15 CFS increase should be a comparison of the post-project runoff to the existing condition runoff. For the purpose of applying this threshold, the existing condition is either the pre-project land cover or the land cover that existed at the site as of a date when the local jurisdiction just adopted flow control requirements into its codes or rules. So the flow control performance standards. Stormwater discharges shall match developed discharge durations to pre-developed durations for the range of pre-developed discharge rates from 50% of the 2-year peak flow up to the full 50-year peak flow. The pre-developed condition to be matched shall be forced to be a forested land cover unless reasonable historic information is provided that indicates the site was prairie prior to settlement modeled or as pasture in the approved model. And we'll look at this in WWHM 2012. The drainage area of the immediate stream and all subsequent downstream basins have had at least 40% total impervious area since 1985. In this case, the pre-developed condition to be matched shall be the existing land cover condition. Figure 134, basins with 40% total impervious area as of 1985 depicts these areas which meet this criterion, where basin-specific studies determine a stream channel to be unstable even though the above criterion is met. The pre-developed condition assumption shall be the historic land cover condition or a land cover condition commensurate with achieving a target flow regime identified by an approved basin study. And so these are some of the basin areas outlined. You can view them in the manual. Then there's an alternate flow control standard. An alternate flow control performance standard may be established through application of watershed scale, hydrologic modeling, and supporting field observations. Possible reasons for an alternate flow control performance standard include establishment of a stream-specific threshold of significant bed load movement other than the assumed 50% of the 2-year peak flow, zoning and land clearing ordinance restrictions that, in combination with an alternate flow control performance standard, maintain or reduce the natural occurring erosive forces on the stream channel, or a duration control standard is not necessary for protection, maintenance, or restoration of designated and existing beneficial uses or Clean Water Act compliance. Flow control BMPs shall be selected, designed, and maintained in accordance with this manual. The objective of this minimum requirement is to prevent increases in the stream channel erosion rates that are characteristic of natural conditions, i.e., prior to disturbance by European settlement. The flow control performance standard intends to maintain the total amount of time that a receiving stream exceeds an erosion-causing threshold based upon historic rainfall and natural land cover conditions. That threshold is assumed to be 50% of the 2-year peak flow. Maintaining the natural occurring erosion rates within streams is vital, though by itself insufficient to protect fish habitat and production. So we'll look at the flow control standard meeting the pre-developed flows and some of the additional requirements. We're going to look at that in WWHM 2012. So for instance, here I have a project, it's a basin. We're assuming 1 acre of sea forest flat. We're going to run the scenario there. Then we're going to meet the flow control duration standard with a detention facility that will help us match that pre-developed flow. So I'll show you here. We'll run through the model. Go to the analysis tab. We're going to look. Oh, we need to run the mitigated. Okay, so we'll run the mitigated. So I'm going to connect this to the point of compliance. So this basin here has 1/2 acre of roads and 1/2 acre of lawn. So we're expecting some development here on this site. Now we're going to run the scenario to see what the runoff is like. Compare that in the analysis tab here, the pre-developed and developed flow as it indicated when we read that from the manual. And we need to match that flow duration standard. And this is using continuous simulation. So if we go here and we look at the pre-developed and mitigated or developed flow, we'll be able to look at that curve. And the model's going to tell you automatically whether this meets or not. So in this case, the facility fails because we exceeded all those flow types. That's why we need the detention facility. The red is the developed flow, the blue is the pre-developed flow. So what we do is we add a detention facility such as a pond. And what WWHM can do is automatically size the pond to meet this flow duration standard. And so we run something like AutoPond, it'll automatically size that facility, and then I'll show you the graph. So after AutoPond is done running here, we'll come back and I'll show you what that facility looks like and how we met that flow duration standard. So we sized this facility here, it was 50 by 50 with this outlet structure, and now it passes the flow duration because we're able to mitigate that flow and meet that range as we discussed earlier in the PowerPoint. So we did our WWHM 2012 modeling. So the objective of this minimum requirement is to prevent the increase in those erosive flows, and the flow control performance standard intends to maintain that total amount of time that a receiving stream exceeds on an erosion-causing threshold. That threshold is assumed to be 50% of the 2-year peak flow. Maintaining the naturally occurring erosion rates within a stream is vital, though by itself insufficient to protect fish habitat and production. And then some supplemental guidelines include the 1992 Ecology Manual. To protect stream channels from increased erosion, it is necessary to control the durations over which the stream channel experiences geomorphically significant flows, such that the energy imparted to the stream channel does not increase significantly. So reduction of flows through infiltration decreases stream channel erosion and helps to maintain base flow throughout the summer months. Infiltration should follow the guidance in this manual to reduce the chance of threatening groundwater quality. So using LID BMPs reduces the predicted runoff rates and volumes, and thus also reduces the size of required flow control BMPs. Application of certain LID and/or infiltration BMPs can result in reducing the effective impervious area and the converted vegetation areas such that the TDA thresholds are not triggered and a flow control BMP is not required. See the definition of effective impervious surface in the glossary for details. Application of BMP T530 full dispersion also results in eliminating the requirement for a flow control BMP for those areas that are fully dispersed. Diversion of flow from perennial streams and from wetlands can be considered if significant existing, i.e. pre-project flooding, stream stability, water quality, or aquatic habitat problems would be solved or significantly mitigated by bypassing stormwater runoff then providing stormwater detention and discharge to natural drainage features. Bypassing should not be considered as an alternative to applicable flow control or runoff treatment if the flooding, stream stability, water quality, or habitat problem to be solved would be caused by the project. The proposal should not exacerbate other water quality and quantity problems such as inadequate low flows or inadequate wetland water elevation. The existing problems and their solutions or mitigation as a result of the direct discharge should be documented by a stormwater engineer or scientist after review. The restrictions in this minimum requirement are on conveyance systems that transfer water to an exempt receiving water, also applicable in these situations. Approvals by all regulatory authorities with relevant permits applicable to the project are necessary. An alternative flow control standard must be compatible with maintaining and restoring the designated beneficial uses for the stream. Basin plans that intend to identify an alternative flow control performance standard will require the use of computer models and field work to verify and support the models. Ecology cautions local governments seeking to determine a threshold of bed load movement for a stream whose channel has been significantly altered from its historic condition by stormwater flows. An alternative flow control performance standard must be compatible with the restoration and maintenance of the designated beneficial uses of the stream. If the current threshold of bed load movement is not compatible with creating and sustaining channel conditions for the beneficial uses, it is not acceptable regulatory target. Basin plans that intend to identify an alternative flow control performance standard will require the use of computer models and field work to verify. So now we can also revising through a basin plan. Basin plans, see Appendix 1B. Basin plans are well suited to control stream channel erosion for both existing and future conditions. Flow control standards developed from a basin plan may be used to alter to the default standards described above and can include a combination of on-site, regional and stream protection, rehabilitation measures, and retrofitting opportunities. On-site standards are usually the primary mechanism to protect streams from the impacts of increased tide flows and future conditions. Regional flow control facilities are used primarily to correct existing stream erosion problems. In-stream protection and rehabilitation measures may be applied where stream channel erosion problems exist that will not be corrected by on-site or regional facilities. However, caution is urged in the application of such measures. If the causes of the stream channel erosion problem still exist, repairs to the physical expression of these problems may be short-lived. In some instances, it may be prudent to apply in-stream measures to reduce impacts until the basin hydrology is improved. This does not alleviate the jurisdiction from needing to ensure that existing and beneficial uses are restored to the receiving water. In-stream work cannot be used to satisfy the minimum requirements under the permit. Retrofitting opportunities may include modified outlets for an expansion of existing detention BMPs. Basin plans may be used to develop an alternative flow control performance standard, identify additional receiving waters as flow control exempt, and identify basins that have been at least 40% total impervious area since 1985 as described before. That is minimum requirement number 7. We went over a modeling scenario there. The next video will cover minimum requirement number 8. So thank you so much for watching, and we'll see you guys in the next video.